Welcome back for the second session of BE Civil Structural. We talked in the previous session about the exam informations and how to apply to the exam if you are in Egypt or in KSA. Now we are going to talk about loads and load combination according to ASCE 716 and IBC 2018, and we will focus on the most important points. The approach that I'm going to follow for each session from this one and forward is that I'm going to divide each one into three parts. The first part we will talk about the code itself, about the main points, so you will get yourself get familiar with it, because as I told in the session 1, it is an open book, so you need to know your way in the code. The second part we are going to give a brief summary for the main points, that like a recap for the part of the code. And the last part we are going to have talk about some questions, and we'll have some examples and talk about their ideas. So let's start. First of all, it is important to know the units conversions that you are going to use, like the metric units, the imperial units, and how to transfer between them. Also, it is very important to know that the density of the normal concrete and the lightweight concrete, because in the exam he will tell you that you have a normal concrete or a lightweight concrete, and he will not give you the density. Okay, so when you when you will consider the own weight of the normal concrete, you will need to multiply by 150 if it is imperial unit. If it is in metric SI, then you will have to multiply it by 24. The lightweight, according to the ACI, it gives ranges from 90 to 115. Usually in the exam we take it 120, and of course we take the higher value because it is the most conservative one. Also for the unreinforced concrete, like plain concrete, then this value will be used. And the steel, the density in imperial unit, it will be 490. So it is very important to know how to this part is very important. Okay, although it is given in the handbook, okay, this handbook it gives you the units conversion like in at the start. But it is good practice to know what you are going to use, because here it gives you like a generic calorie, centimeter, and so on. Okay, but here I give you the most important things that you are going to use. Now let's go and talk about chapter 1. Now I am going to provide some, if you are going to see this, what I'm going to do, as I told you, the first part we will going to talk about the chapter itself. So I highlighted the most important parts, and I am going to leave these codes like international, and of course this one in session 1 you will find it in the session 1. What I'm going to do, I'm going to leave it with the highlighted important parts, so you can go through them and get familiar with the code, because it is an open book. So here I provide the introduction. The ASCE, it is dedicated for the buildings, other structures, and their non-structural component. As we know, like ACI, it is dedicated for the concrete structures. ISAC is dedicated for the steel structure. ASCE, it is dedicated for the, of course, bridges and the roadway design and so on. And here I provided some introduction or some definitions that we know, but in the exam he will tell you that we need to design the beam according to the ASD or the LRFD. So we must know that the ASD, it is a method that uses the nominal load. What is the mean by the nominal load? The actual load with no factor. However, the LRFD, it is the one that is you are going to use the loaded factor, like 1.2 dead plus 1.6 live and so on. So you must understand the difference between the ASD and the LRFD, because he will in the exam he will tell you to design serviceability. Then you know that you are going to use the ASD, or to design the beam to identify the lightest section, like in the steel section when you are design. All of that we are going to see in the this session and the other session and the other ones. Also an important definition, it is the essential facilities and the risk categories. Essential facilities, it is very important because in the exam he will not tell you what is the risk category of the facility. Okay, the risk category, as we will see later, it will affect on the importance factor. So he will tell you the description of the building, okay, the function of the building, if it is a residential, if it is like a facility, storage, warehouse, police station, and so on. You must identify the risk category from this description. Also an most important part, like the basic requirements. This part it can be shown in the exam like a theoretical questions. Okay, not all questions must deal with the equation and so on. Some of them will be theoretical. So if he give you like an example, what are the basic requirements for a safe design, and he tells you strength and stiffness, serviceability, functionality, it is one of the basic requirements. So you must consider functionality, it is one of the basic requirements. Now let's go and talk about chapter 1. Chapter 1, it starts with the most important part. It is about the structural integrity, and it talks about the continuous load bus when a lateral force affecting on a building. Then there must a bus for this load to be able to transfer to the foundation of the column, to the foundation of the building. Like here, if I have like a building and I have a lateral force acting here, we all know that the roof will act as a diaphragm, and we have a lateral resisting system, whether it is a moment frame, okay, or like a shear wall. So through the diaphragm, it will transfer this lateral force to the lateral resisting system if it is like a shear wall, and it will be able to resist it. So it establishes or states that there must be a continuous load bus. And according to this part, it mentions that if like a smaller portion of the structure shall be tied to the remainder of the structure with an element having a strength of at least 5%. As you can see, the most important values, okay, I highlighted here because it is usually shown in the exam. Like this one, what does it mean? So if we have like a building here, okay, so we have this building, and we have like a smaller part of the building, like a storage house or a guard house or whatsoever, and it has a value, and its weight is W1, and it is connected to this structure through this element. Maybe if it is a steel, he can tell you what is the minimum force that this connection needed to be designed. So if we see, and he will give you like the statical system of this part, it will be like a fixed column, and the connection of the beam with the column, it will be like a roller, and with the building, it will be like hinged. So it is statically determinate, and it is a stable structure. Okay. You need to design this connection. So you must consider at least 5% of the portion of the weight. Okay. So you must consider this 5%. Also, he talks about the lateral forces. If you have a building and it doesn't have any lateral force acting on it, like seismic or wind or whatever, then at least 1% of the dead load must be considered. Meaning that if you have like a 3-story building, okay, it is like a question in the exam, and he tells you what is the minimum base shear that the structural will able to resist. The minimum, okay, and he will give you like a dead plus life for story 1, and dead plus life for story 2, and dead plus life for story 3, and he tells you what is the minimum. Then it will be 1% of the summation of the dead load. Okay, that is the minimum force that you need to consider. Also, this value is mentioned in ASCE in chapter 12, as I recall, in 80, not in 89, but in the minimum value when we are going to calculate the CS value. As I recall, the minimum value, it will be something like that. Here it mentions that the CS shall not be less than 0.01, of course, multiplied by the weight. Okay, and the weight, it is the effective weight, which is the dead weight. Okay, so this value it is satisfied, it has been met in the seismic accordingly. So let's go back to chapter 1. Okay. So the 1% it is very important to consider. Also the connection to the supports. The connection shall have the strength to resist a force of 5% of the unfactored dead load plus live load. So if we have like a beam and another beam and a beam connected to them, the secondary beam it has like a dead load plus live load, and he tells you to design this connection. So the first thing you will consider the load combination. So it is a strength design. So I must consider the cases 1.4 dead plus 1.4 dead load and 1.2 dead load plus 1.6 live load. Okay, that is a vertical force, and we must consider a lateral force which will be equal to 5% of dead load plus live load. So it is also important to consider this. Also, he mentions a part of he mentions a value for the anchorage of structural wall. Like if you have a structural wall and the anchorage with the roof or floor, it must satisfy a force of a minimum of 0.2 multiplied by the weight of the tributary to the connection. Okay, meaning that if you have a wall and the anchorage here, so if we consider this tributary area, then this connection it will have a lateral force of 0.2 multiplied by the weight of this shaded area. Okay, and this value must not be less than what this value 0.24 kilonewton per meter square or 5 bsf. It is very important to focus on the minimum values because it is one of the tricks in the exam that you wants you to solve something, and this like wind load it has there is a minimum wind load. So after calculating the actual force, you must check with the minimum value. Okay. Now let's talk about the risk categorization. As I talked before, it was called occupancy category in UBC 97, but it was mentioned, but the name is changed into risk category. And the risk category it defines the importance of the structures. Okay, it is based on the risk to the human life, health, and welfare associated with their damage or failure by nature of their occupancy or use. So for storage shelter, it will be risk category 1. 1 it is the least important, and 4 it is the most important. Okay, storage shelters there will no people habitated in it, so it is considered as 1. It is considered the criteria it is unoccupied. It would result in negligible risk to the public should they fail, so it is not important. Risk category 2 it is used for the residential, commercial, and industrial building. Okay, that is important. For theaters, lectures, and so on, like housing a large number of persons, that is the criteria, then it will be considered 3. And for like hospitals and police station, fire station, which is represented by essential facilities. In the exam, he will not tell you what is the risk categorization, but he will tell you that we have a residential building, we have a storage shelter, we have a hospital. So you will understand that it is a risk category 4, 3, 2, or 1, which would result in what? In the importance factor. It affects the importance factor for the seismic, for the wind, and for the snow. Of course, for the wind it is only 1, but in ASCE from ASCE 710 it provided more maps, and each map is corresponding to a risk category. Okay, so when I'm going to use risk category 2, I will use a map different from risk category 1 and different from 3 and different from 4. And as you can see that the risk category affecting the seismic importance factor 1.5 and 1.5, and also for the snow. So when we will go to the session for the snow design or the wind design or the seismic design, we must go for chapter 1 to define the importance factor and to define the risk category. Now let's talk about the load combinations. I give a brief for the load cases, the abbreviation for the load cases that's being used. And for this part, I am going to refer to IBC building. Regarding the IBC, it is very important to focus on chapter 16 because it is one for the structural design. It is very important. and especially here for the load combination IBC, it is more like it is more detailed than ASCII. As you can see, there is F for the flood, okay, and also there is an H. H is for the lateral earth pressure. It is very important to understand what H means and the F means and so on. According to ASCII 716, it doesn't mention 1.4F explicitly, but it is shown as a text. Meaning what? Meaning that he gives you like a guidelines where fluid loads, if are present, they shall be included with the same load factor as the dead load D. And that is what is IBC shown. There is a bracket for the dead plus F. Okay. Regarding the lateral earth pressure H 1.6. Okay, let's go there. It is 1.6. Okay, so it is very important to see that. Okay, and as you show that, as you see, I highlighted the most important parts. Okay, so too easily for you to get familiar with them, and for like the exception for the load factor L here, also the load factor L for the live load, it can be used half. Okay, the load factor can be used half, except that if the live load is more than 4.78, then you will use it as a 1. Also, I mentioned it here. The half value in case of live load is more than 4.78, it shall not be used. F for fluid loads and H for the lateral earth pressure. Also, this load combination are for the ASD, so that is for LRFD. So when he will ask about a question regarding the strength design of a beam, so you will need to use these factors as I showed before, the 1.2 dead, 1.2 dead plus 1.6 live load. So that is important to understand that. Also for the allowable design, which will be used for the serviceability check if he asked about any serviceability requirement. Now for chapter 3. Chapter 3, it is an easy one. It is almost 2 pages in ASCII 716, but it contains important information. The first thing that most people forget when they focusing on solving some problem is the own weight. You usually forget about the own weight of the beam, of the slabs, and so on. So I highlighted in red, you must consider the own weight. Unless in the exam he mentioned explicitly you don't need to use the self weight. Don't consider the self weight, then you shall not consider the self weight. Okay. The second important thing here, it mentions that what types of the dead loads. We all know that the dead loads it consists of any sustained load like cladding, HVAC, like floor cover. If you have an equipment, okay, if you have like a bridge crane, so the bridge crane it has a dead weight of like this crane, this tower crane, it has its own weight, so it is dead load. Also, there it can lift anything like the rated capacity. It is the live load, so you must consider which one is the dead load and which one is the live load, because when he will ask you about the like a strength design, it will affect on which one will be multiplied by 1.2 and which one will be multiplied by 1.6. Also, the most negligible part, maybe most of us don't know about it. Chapter 3 provides a preliminary earth pressure can be used for design a retaining wall, and it depends on the backfill material. So let me draw something. So if in the exam he mentions that you have a retaining wall, and of course anyone will hear about a retaining wall, he will go and run to ASCE. Okay, that is the one that I'm going to use to solve this problem. Okay, that is one of the tips and tricks of the exam. Okay, he mentions a retaining wall, but he will not give you enough information to use ASCE. He will not give you like the file. Okay. He will give you like the backfill material. It will be like GW. Okay, and he tells you what is the overturning maybe here, what is the maximum moment here. Okay, So the overturning, if he wants to know about the overturning or sliding or whatsoever, then it is ASD. Then you will have to use the ASD load factor. If you want to define what is the maximum moment that the retaining wall will be designed on, or what is the maximum pressure, the maximum pressure, it will be ASD. However, if he wants you to design the maximum moment for this part, it will be LRFD. Okay, so it is important to know which one you are going to use. And he tells you that he wants you to design it, and he mentions that the type of the soil is GW. ASCE gives you preliminary values. Like for the GW, it will give you, like if it is a metric unit, then you will have to use the value in between the brackets, and if it is imperial, then you will have to use the value not in the brackets, like 35. 35 it is in BSF, and 5.5 it is in kilonewton per meter square per meter depth. What does it mean by the meter depth? Means that the force will be like something like that, 5.5 multiplied by h. So if I have a retaining wall of h equal 1 meter, then I will have a 5.5 kilonewton, okay, per meter square, because the value of 5.5 it is kilonewton per meter square per meter run, or per meter depth, not meter run. Okay. And this value, it is actually almost equal to the one that we used if we have like a gamma soil of 18, okay, and we have a K active of which is corresponding to 1.1 subtract sine 5 and 1 divided by 1 plus sine phi, which usually result in a third. So you will have like gamma multiplied by K active multiplied by the h, which is 1 meter. It will give you 6 kilonewton per meter square, which almost equal to 5.5. So it gives you a very good start to start your design without any geotechnical report. So as I told you before, if he mentions that you have a retaining wall and he doesn't give you enough information, don't go run to ASCE. You can use chapter 3 in ASCE to determine the force. Also, it is important to know that he gave you like node B. It says what? Let me start again. If you have like a retaining wall, but not a retaining wall, like a basement, okay, and there is a floor here, and it is flexible, and maybe it is rigid, okay. Here in the note it says that if the diaphragm or if the floor is flexible, then you will use the value 5.5. If it is rigid, then this value not 5.5, but it will be increased to let me see, to 9.43. Okay, so it will be increased to 9.43 because this part of rigidity will increase the amount of pressure that will act on the retaining wall. So it is important to also read the notes that is given here, because another example, he tells you that if the basement walls extending not more than this value, okay, then it will be considered as relatively rigid walls, okay, being relative are not considered, okay. That is the tips and tricks in the exam that will give you like a basement wall and the wall height is less than this value, then it will not be considered as rigid and it will be considered as a flexible, and you can use this value directly, okay. That is the idea of chapter 3. Now let's go back and talk about chapter 4. Chapter 4, it is very important because it is dedicated for the live load, and here we will mention the minimum live load for each different element. Like for the grab bar system, it mentions the minimum load and the direction, and it is important to know the direction of how to apply this force. Here it mentions any direction, okay. Guardrail system, the minimum force is this one and it is used in any direction. Okay, it tells you that the handrail and guardrail system, here it is a concentrated force, it is in kilonewton, and here it is a kilonewton per meter run, Okay, also it mentions the minimum value for vehicular barrier. So if like another example, if you have like a guardrail, okay, guardrail, and that is a guardrail, that is the posts, and this one is the guardrail, and he tells you what is the maximum force that you need to design this post. Okay, the maximum force and what is the minimum force. So what is the minimum force and what is the maximum force? Okay, the minimum force or the maximum force, we will have to go back here, and here it tells you that the force is 26.7 kilonewton, and the point of application ranges from 460 and 2686. Here I will multiply by 6.7 multiplied by 464, and here multiply by 686, correct? To get the minimum and the maximum value, so to need 460. Okay, this one is 460. That is the tips and the tricks in the exam. What is the minimum, what is the maximum, and so on. Also, one of the tips and the tricks that I had in my exam, this one, in any direction. Okay, I recall in the exam he gave me a post, okay, of a height h, and it is connected to ties. Okay, this is a tie. Tie means it carries only tension force. Okay, and that's this distance like L1, and this one is L2. Let's say this point is an A. And we have a force of a guardrail, then it of a handrail, then it concentrated, it will be 0.89 kilonewton. And he tells me, he asks what is the maximum tension force that the support can carry. Of course, I didn't consider the reverse direction, so anyone will take the equilibrium about moment A. It will be something like 0.89 multiplied by h divided by L2. You will get this vertical force. Okay, however, the maximum force it isn't here. Okay, when it is reversed, then it is in the opposite direction. This one will have the maximum force. So it is very important to understand also the direction. When he tells you in any direction, and he tells you that you have a guardrail system or you have a handrail system, and he give you the direction here, okay, you need to reverse it. Okay, you need to check in the other direction. This one has like a 5 kilonewton tension force, and this one it has like a 10 kilonewton. So the maximum force it will be 10. Also, another tip and tricks in the exam, this 5 kilonewton will be given in the answer. Okay, so you will consider I found the answer, so I must be correct. No, the 5 and the 10 will be in the answer, so you have to consider the 10, of course. Now let's talk about the live load itself. ASCE provides a table for the live load. Also, as you can see, I highlighted the most important part here also. These tables, that is the minimum, okay, that is the minimum uniformly distributed, and it gives you the value of depending on the occupancy of each one, and it tells you if this value can be reduced or not, and if it is a multiple story live load reduction. Okay, because if it is a one story, sometimes it cannot be reduced. However, if it is like more than one story, it can be reduced. And it tells you and gives you another check or another value can be used, which is concentrated. The concentrated force here, it will act at a here it tells you that the concentrated load, it would act at an area of 762 multiplied by 762, okay, and shall be located as to produce a maximum load effect. This value, we actually use it as a local check, not a global check. So if I have a building and I am going to design, then I will have to, I am using these values. But if I have a local check I'm going to use, if I'm going to design like grating maybe, then I check the concentrated, and I will check with the uniform live load. Okay, and as I show here, that is the important part that you are going to use. Also, you must consider like for balconies and decks, it tells you that 1.5 times the live load for the area served, but not to exceed this value. This is most important because he can give you like let me have one here. So if this is plan, okay, and that is the column, and this is beam, and that's a column, and that's a column, and he tells you that it is an office maybe, and that is a balcony. Okay, and he tells you to design this beam. So you will have to use the area method. Okay, so this this area will be served by this beam, and the live load here, it will be as I recall. Let me see the offices. Okay, office buildings, lobbies, and the first floor corridor. It is 4.79. Offices 2.4. Okay, so the offices I have a value of 2.4. Okay, but balcony it will be 1.5 multiplied by 2.4. Okay, that is the idea of the exam. It is very simple, it is very forward, but you must understand each thing. So if you have like a balcony or a desk in like a plan he giving to you in the exam, you must understand that this part will be treated need to multiply by 1.5, but not to exceed this value. So it is very important to apply this value correctly. So I highlighted, as I told you, is the minimum, the usual values that you are going to use. Roof, the minimum value is 0.96. Okay, so let's go back here. Regarding the partition load, the partition load, it says, it mentions that you must consider the partition live load, which is 0.72. So if in the example it tells you that this one also, okay, so that is office, so there must be partition. Okay, there will be partition load to consider, which is corresponding to 0.72. But here in ASCII it can exclude this value if the live load is more than at least is 3.83. So if the live load is at this value, you can neglect the partitions. Okay, يبقى here in office buildings اهو. Okay, that is explicitly mentioned in office buildings. So as I mentioned here, if this one is office, so the live load corresponding to the table is 2.4, and if this part is a balcony, then you need to multiply by 1.5. Also, don't forget about the 0.72. Okay, that is the idea of the exam. If I told you it's an office, then you must understand that. If I told you that is a balcony, then it will be 1.5. Okay, that is the idea of the exam. Concentrated live load, as I mentioned, it is for local design, and it will affect on an area of 2.5 feet multiplied by 2.5 feet. It is a square. Okay. The table I mentioned here, it depends on the occupancy or use. That is the uniform L node, and the live load reduction. It tells you it can be or cannot be. For the assembly areas, there will be no live load reduction. Okay, the assembly areas, they are areas dedicated when there is like an earthquake event or a catastrophic, or where the people should come together in a safe place. So you cannot reduce the live load at these areas. Also, the impact loads, it is very important here. The impact loads, as I recall, it mentioned here, the impact loads, yes, for the machinery. Because in the exam he will tell you that you have a lightweight machinery, and of course if you have a lightweight machinery, then you need to multiply by the live load by 1.2. Okay, and for reciprocating machinery 1.5. So he will not tell you you need to multiply, but he will tell you that you have like a simple beam, okay, and you have like a dead weight, and you have like a reciprocating machine here with a value of like 50 kilonewton. Then you will have to consider 50 multiplied by 1.5 as a live load. And if you are going to design on LRFD using LRFD method, then it will be 1.2 dead plus 1.6 live load, or 1.4 dead. So you must consider the impact, because that is a machine. Okay, as I recall, for elevators, he tells you to go to ASME A17, so he doesn't give you any information about elevator. So that is important. I highlighted it for you, like 20% and 50%. Also, he mentions here if elements supporting hoists for facade access and building maintenance equipment shall be designed for a live load of 2.5 times the rated load. It is very important to know these values because sometimes he will give it to you in the exam. Okay, another important thing is the reduction of uniform live load. It is very important. The criteria for any reduction, it is based on this factor KLL multiplied by the area tributary. If it is more than 400 feet square, which is corresponding to 37.16 meters square, then the reduction can be done. And the live load is less than 4.79. That is the two criteria that you can use the live load reduction. Okay, the KLL factor, it depends on the element. If it is interior column, then it will be like 4. And if it is like edge column with cantilever slab, it will be like 3. If it is corner column with cantilever slab, it will be 2. So in this exam, this one can be considered as 2. Okay. And here, if it is a corner column with cantilever slab, 2. Edge beams without cantilever slabs. So you must understand this, and it depends on the case that you are going to use. This one is can be shown in the exam like the same of this. He can give you like a big plan, okay, and it tells you that you have a column here and a column there and so on. Okay, he give you the distance. Okay, and it tells you this part is like office or residential or whatsoever, and he tells you you need to determine the maximum load acting on it, or if it is like a concrete column, you need to design it. Okay, so you will need to get the force acting on it and to design it. Okay, that is the idea of the exam. So you will have to get the tributary area, the area method. That is the area that will be served by this column. Okay, and you will have to check that this factor multiplied by the area tributary is more than 400. Okay, and according this that is office, so the live load is 2.4. It is less than 4.79. So we can reduce the live load. So when you are going to design it, you must consider reduction of the live load. That is one of the tricks of the exam. He will not tell you use the reduction, but according to the case that is shown, this criteria has been met, then you need to reduce the uniform load. Of course, there are limits, meaning that if the L reduced, okay, shall not be less than the half value. If it is the member supporting one floor, so that the column is supporting like this column supporting only one floor. Okay, this like this one floor, one story, that is an elevation. Okay, that is the case. Then it will not be less than a half. So you must check the minimum, the limits. If it's supporting 2 or more, then the L reduced shall not be less than 0.4. Okay, as I told you before, these criteria must be met. However, there is an exception for this criteria. If the live load is more than this value, okay, and supporting 2 floors or more, then the L reduced will be the larger of this equation, which is the equation this one, okay, or 0.8 L naught. Okay, so if the equation gives you like 0.6 L naught, you will use this value. If this equation gives you like 0.9, then you will use the equation. Okay, you must understand the idea of reduction, because it is one of main points that usually shown in the exam. Also, I highlighted here for the roof. The roof also it has a reduction. So if he give you like a warehouse, like for an example, starting with a new one. So he will give you like a storage place. Okay, that is the main system. Okay, and he tells you to calculate the area for the main system here. Then you will have to check the area attributary for this part also. That is the first thing you are going to do, the area tributary. And after that, after checking the area tributary, if it is here, if it is what type, if it is less than 200, then the R1 factor will be 1, and so on. And then you will have also to check the F factor. Okay, what does it mean by the F factor? Let me go back. So if I have this type of building, the F factor in SI units, it will be what percent? What does it mean? If I have this one is 12 meter and the height is 1 meter. Okay, the height is 1 meter. So this one is 6, this one is 1. So the percentage is 1 divided by 6 multiplied by 100. Okay, that is the percentage. Okay, and this one will need to be multiplied by 0.12 as mentioned here. That is the slope. So after getting the slope, which is corresponding to 1 divided by 6 multiplied by 100 multiplied by 0.12 in SI units. Okay. Regarding the imperial unit, it is the number of inches of rise per foot. What does it mean? So the same one. If I have this one is in feet, so I have let me draw it again. So if this one is 6 feet, okay, and the height is 1 feet. So here it mentions that the number of rise in inch. So I have 1 feet. What does it mean by 1 feet? 1 feet is equal to 12 inch. Then it will be 12 divided by 6. The F, it will be equal to. Okay. However, in the case of SI, it measures the theta, which is h divided by this value multiplied by 100 multiplied by 0.12. So you can calculate the reduction factor. Also, it is important to consider the reduction factor of roof livelihood, and as I told you before, he will not tell you to use the reduction, but you need to check the criteria, the R1 factor and the R2 factor. Okay. Now let's talk about the crane loads. The crane loads, it is most important because especially for the impact forces. Let me go to this. That is a picture of a mono of a bridge crane with supported on 2 girders. Okay, as you can see, that is the track of the crane, and that is the trolley and the hook, of course. And of course, if it is carrying if it is carrying anything like a valve or whatever, it will be supported here. So the crane load, it is a live load because it is a movable load. Okay, and as you can see, I summarized the factors, the impact factor for these loads. So when the trolley is positioned here, okay, near this support, the factors that you are going to use, if you are the vertical impact force, it depends on the type of the crane. So if you have a monorail crane, then it will be multiplied by 25%. If you have a bridge crane or monorail crane with hand geared bridge, it will be 0. If you have a cab operated or remotely operated bridge crane part, it will be 25%. Like this one, it is a 25%. So I wrote 25%. And of course, as a lateral force, it will have a 20%. So you will have a 20% lateral, and it will resist it from this part and from this part. So if they have the same stiffness, then 10% at these supports and 10% at these supports. And for the braking force, it will have 10% of the maximum wheel force. Okay, the maximum wheel load. Lateral force, it is a 20% of the rated capacity of the crane plus hoist plus trolley. It is important to know these values. And the 10% of the maximum wheel load, meaning the maximum wheel load, it doesn't consider the impact of the maximum wheel load. Okay, yeah, but the 10%. So if you have a maximum wheel load is, let me draw it. Okay, let's make a new. So if you have like this wheel, that is the wheel of the crane. Okay, that is the wheel of the crane, and the trolley is positioned here to get the maximum force. That is the maximum wheel load. It will be like P. To consider the vertical impact, it will be 1.25, and to consider the braking force, it will be 0.1 multiplied by P, and to consider the lateral force, it will be 0.2 multiplied by, as mentioned there, trolley 20% of the rated capacity plus the hoist plus trolley, not the bridge weight. Okay, so the lateral force will not consider the dead weight of the bridge, but will consider only the moving weight, like the trolley, like the hook, like the rated capacity. So it is important to consider that the 20% includes only this one, not the own weight of the bridge. Okay, and that is the idea of the crane. It is important, and we will going to see it especially for the influence line. Now that is the second part. As I told you at the start, that I'm going to divide it into three parts. That is the second one. So the main points: the minimum lateral force is 1% of the dead weight. Of course, the risk category and importance factor, because you are going to use it in the other chapters, like in snow and seismic and wind and so on. Of course, don't forget about the lateral soil load, because if he doesn't give you enough information, if you have a retaining wall and so on, then don't go rushing to the ASCE. You should consider ASCE also, because it gives like a preliminary values. Of course, the load combination, that is the most one that is being used for the strength 1.4 dead. Don't forget about the 1.4 dead, because sometimes he will give you like a simple beam with dead and live, and the dead load is more dominant than the live load. And of course, you will forget about the 1.4 dead load, and you consider only this one. So when give you dead and live and wind and snow and so on, you must consider the load combination as we talked before in chapter 2 in ASCE, or chapter 16 in IBC. Of course, also don't forget about the own weight. If he explicitly mentions that you should neglect the own weight, then neglect it. Okay. Of course, the impact load, if he mentions that you have a light machine, if you have a reciprocating, what does it mean? That you need to multiply the forces by 20 or 50%. Okay, don't forget about it. Crane load don't forget about the crane load, as we mentioned here. The 20% doesn't include the own weight of the bridge. The 10% includes the maximum wheel load. Okay, and depends if the bridge crane like hand geared. If it mentions that it is hand geared, then there will be no vertical impact. It is very important, because the impact it will be zero if it is hand geared. Of course, the vehicle and wheel load shall be increased by 30%. Okay, that is a point also mentioned there. Like when vehicles passing through expansion joints or joints through a bridge. Okay, then it will be increased by 30%. It is mentioned there, I think, 30%. As I recall, it was mentioned here. But of course, you should go back to ASCE for this one. Also, the reduction for the live load and roof load, you must consider them. As I told you, he will not tell you that you should use them, but you must consider them in the examples. Now for the last part, which is related to the examples and the questions. The first example, it is a very straightforward equation. It tells you, it gives you a typical floor for a three-story building, and tells you to compute the live load for each one of them. So you will have to go to the table. Okay, and of course for the roof, the value is like 0.96, and for each occupancy you will get the corresponding live load, and you calculate it directly. But this question, it is important to notice that for this elevation he may not show it to you, and just satisfy with the three-story building. And the three-story building, it will affect on the limitations for the L reduced. The L reduced for one floor it will be a half, and for two or more floor it will be 0.4. So careful should be taken when reading the question. You need to read it very carefully, and for every information you must highlight it because it will lead you to an answer. Okay, so this is an important. Also, for this part, he give you like an offset and the conference room. So if we have like a column here, or this corner column, and he will give you like the distance, it is an equal spacing, so 45 divided by 4. You calculate the attribute area for this one, and you can get the value acting on this column. Okay, if you have like we have a column here, maybe let me draw something. If we have column here, okay, so that will be the tributary area of this part, and you can calculate if the reduction can be used or not, if it is applicable or not, this area is more than 400 feet square or not, and then you can calculate the actual forces on this part. If you have like a beam and so on, so you get the idea. He can provide you a typical floor plan and tells you that we need to calculate the forces, or we need to design the column, we need to design the beam or whatsoever according to the loads. Then we have the live load, we have the dead load, and of course you after getting the load you can design it and so on. The second, okay, that is continuous for the example one. The live load on the roof, it will be like this. That is the answer of it, and it will give you like the forces that you are going to get from the table. Example 2, it is an easy one. Also, he tells you what is the total service load reaction at support A. So that is the support. It is a hinged roller. It is a statically determinant. So the equilibrium equation you should apply it. However, as I told you before, the own weight of the beam will be forgotten. Okay, so don't forget about the own weight of this beam. Okay, he doesn't give it to you the main span, the floor load, the internal wall, the railing, and so on and so on, and he tells you that the section type is W14 multiplied by 90, and in the section for the ISCE, for the steel especially, we will understand that this is 90 it is a pound per feet. Okay, and if you need to convert it to kilogram per meter, you need to multiply by 1.5. Okay, so in the idea of this example, you should consider the own weight of this beam. Okay, that is the main idea of this example. Another example, it tells you determine the maximum deflection of the reinforced concrete beam shown below. Okay, he show you that here it neglects the beam self weight. So he explicitly mentioned that the self weight of the beam should be neglected. Okay, so that is the most important. The equation like for the delta maximum, it can it's shown here. Okay, go to the book, the force of structural. Okay, and it gives you the values for the simple beam concentrated load at center. Okay, so that is the delta maximum. So you don't need to know the values because it is already mentioned in the handbook. Okay, so you can use the handbook for this type of questions. Here he used the I gross, okay, not the I effective and so on, but according to the ACI, as we are going to get it when we have the session for the ACI, we shall know that this I, it will be the I effective, and we will know how to calculate it. Okay. The fourth example, the idea of the fourth example is that he gives you an extra data. Okay, let us read it. So he tells you that he needs the net allowable soil pressure for a square isolated footing that supports a column of 22 multiplied by 22 inch. The service load is this, and the live load is that. The gross allowable soil bearing capacity is 6. Okay. The base of the footing is located 4 feet below grade. The width of the soil is 125. Assume a footing thickness of 2 feet. Okay, so what is the net allowable soil pressure? We all know that the Q gross is equal to Q net add gamma multiplied by df. Okay, the Q gross he is giving to me is 6. Okay, Q net that is what he wants, plus gamma of the soil is 120 pound per cube feet multiplied by the depth, which is 4 feet. This one is in kips, so we need to divide it by 1000, so the Q net will be 5.5. okay, and the answer is here 5.45. so you will the answer is this one. So the idea of this equation is he gives you a lot of data and extra data that you don't want to know, the dimension of the column, the thickness of the footing, the dead load and the live load, but I don't want all of that. I just want to get the net soil pressure. Okay, that's it. The people that are dealing with the geotechnical report is in the geotechnical report he actually gave you the allowable and he gave you the gross. Okay, he is not concerned with the types of loading that is shown here. So let's go back to for the example 5. I show you like 2 examples, and the idea of these 2 examples that how to use the load combination. So here it mentions that if a steel plate is subjected to a tension load of 10 kips and a tension live load of 15, what is the demand design load? Here it only concerned with 1.2 dead plus 1.6 because it is the one that is governed, but don't forget about the 1.4 dead load. Okay, so in here you must deal with also check with the 1.4 dead load. You must consider this one also. Okay, because maybe it will govern, maybe this one it give you a concentrated load and it tells you what check the adequacy. Okay, so he give you like this type of section and you just need to check the adequacy. Okay, so you will also multiply 1.2 dead load plus 1.6 live load and so on, and of course you should consider also the own weight. Okay, don't forget about the own weight of the beam. So in this equation you should consider the own weight, okay, with the dead load, and also consider the live load, the factor of 1.6. Question 6, it is also an easy one. He tells you select the lightest section. Okay, here when he mentioned explicitly the LRFD method, so you will have to use 1.2 plus 1.6. He tells you that the assume including the beam weight, so you shouldn't, so you no need to consider the own weight or to repeat it again after discovering what is the lightest to recheck again. He tells you that is the force including that is the weight that is including only all the beam weight also. Okay, let me see this one. Okay, that is another one. He tells you in this example we have a 3-story. Okay, so you should consider the reduction. Okay, you have a brick veneer as a unit weight 40. It is an office building, so you can consider the live load of the office building. Shown is framed with that is the material of the structural steel. Assume simple connections, so it is mean a simple hinged simple beam. The floor dead load is 60 and the floor live load here it mentions explicitly the floor, but if it didn't mention it we should get back we should get it from the table. Okay, there is a braces with a spacing of 10 feet provide lateral support for all horizontal beams. Okay, meaning that it is the lateral support, there will be no lateral torsional buckling. Okay, he tells you what is the lightest size of a third floor spandrel meaning an edge beam for a typical 30 feet by 30 feet bay using an LRFD. So here it gives you like 6 bays. Okay, each bay is 30 feet and the distance between these secondary beams is 10 feet. It is an equal spacing. Okay, and he wants you to, okay, let me draw. That is the one that is a spandrel beam. Okay, that is a spandrel beam. He want you to check, okay, what is the lightest side of the third floor spandrel edge beam, okay, BC, for a typical 30 feet by 30 feet using LRFD. So in this case, you have you have a floor of 60, and you have a light load 40, and don't forget about the brick veneer, okay. Because it is a spandrel, there will be of course that is the third floor, okay. It is not the roof. Third floor, it is not a roof. So you have a brick. Don't forget about the brick. So you have a dead load, you have a live load, and you have a brick wall, and that is the one. The 30 feet is it will be like a simple beam, okay. That is a 30 feet. So you will have to calculate the forces on the beam, and then check the minimum first using the LRFD. So don't forget about 1.2 dead plus 1.6 line, okay. And of course, regarding the dead load, it will include also the brick wall and the on weight, okay. That is the idea of the question. It is an easy one and straightforward, okay. Okay, someone will tell me, how about the live load reduction? Okay, let me see. The area tributary for this beam, it will be like what? It will be very small, okay, because there is a secondary beam here and secondary beams there. There is a lot of secondary beams, so the tributary area for this part, it will be of course lesser than 400 feet square, so there will be no reduction. Okay. Example number 7. The example of this, it is also it is an important. He gives you like a beam, okay, and it gives you like a column, and in this column it gives you there is an expansion. So from this picture you can draw the statical system, okay, that you will have a roller, okay. This one, it will be like a roller, okay, and that is a cantilever, and this one is hinged, so it will be something like that, roller and hinged, okay. He tells you to calculate, let me read it. The second story floor of a light storage warehouse is supported by a series of identical adjacent beam column assemblies. The beam and the girder are attached using a single slot. The slot meaning that it is a roller connection. The design requirement set forth in ASCE neglects the length of the beam girder nodes may be reduced. Okay, so he give it you explicitly, there is no reduction. So it is subjected to a live load of 0.1. Okay, and there is a loading of 8-inch thick lightweight reinforced concrete. That is an 8-inch lightweight concrete. So the values that you are going to use, the density, it will be 120. Okay, BCF. That is very important because we are using the imperial units. And the spacing of the beam column assembly is 20 feet. So what does that mean by that? That this system will be repeated again each 21 feet. Okay. The ultimate factor, the ultimate factor actually transmitted to the column at section AA is most nearly. Okay, so you have a dead load, and you have a live load, and you have the span. Don't forget, that is the main idea. And the main idea. Don't forget about the on weight. This thing, that is the most important. The on weight of the beam, you will forget about it. You will consider the slab, you will consider the live load, and so on. Okay, but you will forget about this 35, the 53. It is very important to consider it. Okay, and after considering it, here it tells you the ultimate factor load axial. So you will consider the case 1.2 dead plus 1.6 live, or 1.4 dead load, which one is the maximum, and you will choose it. Okay, that is very important question. 8, okay, that is a theoretical question as I told you before. It tells you, according to ASCE 7, all parts of the structure between separation joints shall be interconnected to form a continuous path to the lateral force resisting system, and the connection shall be capable of transmitting lateral forces induced by the parts being connected. Any smaller portion of the structure shall be tied to the remainder of the structure with elements having a strength to resist a force of not less than 5% of the portion's weight. If you don't know about this, okay, in ASCE, it will be difficult for you to discover it in the exam. It will take some time to consider the minimum value of the 5%. Okay, so that's why I'm telling you, you must get familiar with the code. You must read it a lot, so you will be able to solve it and to be able to expect anything. So that's all for this session. The requirement from your side to read the code because that is the thing that will be with you in the exam. For the parts that I didn't focus on, okay, there are some parts I didn't focus on, just read them, okay, to get to be familiar with them. As I told you, maybe a theoretical questions will be given in the exam, so be prepared. Thank you and see you later.